So in this video, we're going to look at some methods from the math class. Okay, in previous videos, we talked about the mathematical operators. So for instance, if we did system.out.println, we could multiply 2 times 2. We could add a number. So we could do a +4. We could subtract a number. And we could divide, and we could also do modulus. And those are the operations that are part of Java. So Java will recognize multiply, divide, modulus in order from left to right, addition and subtraction then from left to right. Now, if we wanted to do an exponent, you need to be careful because Java does not recognize this up caret as an exponent. I believe Python does, but Java does not. So if we wanted to raise 2 to the 3rd power, we would need to be doing 2 times 2 times 2 to get 2 to the 3rd power. And that can get tedious, obviously, the higher the exponents. So what we do for exponents instead is we're going to go to the Java Math API, and we're going to take a look and see if we can find a method for exponents. And I think it's called power. So we'll scroll down here and find the power method. There it is. Okay, now this in the Java API, this is called the signature of the method. It explains what the method declaration is going to involve. Okay, so it's a static double, means it's going to return a double. Static means that there's one instance of this method. It's going to apply to the whatever object it's called on. And the parameters, the arguments are a double and a double. Okay, so double A, double B, and the values get passed by parameter, right, into the function, and it's going to return the first argument raised to the power of the second argument. So in JGrasp, okay, we can go ahead and call this method. We invoke the class math. Remember, classes have a capital letter, and then .pow for power. And remember, the first number we put in, that'll get passed by parameter into the method, and then the second is the exponent. So the 2 is the base, the 3 is the exponent, and that would take 2 raised to the 3rd power. So let's go ahead and compile and run. Whoops, oh, forgot my semicolon. There we go. We'll run again. Okay, and there's our returned value. It's a double 8.0 that got printed to the console. Okay, let's take a look at some of the other methods in the math class API. So if we scroll up here to the very beginning of our list, okay, we've got an absolute value method that accepts a double, a float, an int, or a long. And whatever the data type is that you put into the function, that's what's going to be returned. So if I use my absolute value method and I pass an integer into it, right, it's going to return the absolute value as an integer of that integer. Okay, remember float, you would need a lowercase f at the end, so that's how it would recognize the difference between a float and a double. And then a long is a long integer, and you'd use a capital L at the end of the data to differentiate between an int versus a long. So we can go ahead and try those methods. So if we do math.abs and let's put in -5, okay, then we will Control C we'll copy and paste, and let's do a positive 2.7. Okay. So we'll go ahead and compile and run. Okay, and there's our output. So notice we input an integer, and the absolute value of -5 was returned as an integer, positive 5. Right? We put in a double, 2.7. The absolute value of 2.7 is 2.7, and it returns that value. Okay, so let's go back over to the API, and we'll look at what other interesting things we can find in this list of math functions. Right? So here's our ceiling function. That's going to return the value that we enter as a double. It's going to round that double up, right, to the smallest double value that is greater than or equal to the argument. So if I wanted to find the ceiling of 2.7, right, that would round up to 3. If I wanted the ceiling of 2.1, that would also round up to 3. Okay, then we have some of our trig functions like cosine. Here, there's a sine function, a tangent function. One that I would caution you about is the log function. So let's scroll down here and find log. Okay, this is a trouble spot for a lot of computer science students in Java because in math classes like pre-calc, calculus, the log log of a number is assumed to be base 10, and then we would use ln, the natural log, for base e. But in Java, that's not the case. In Java, base e is log. There is no ln in Java. And to get a base 10 logarithm, you have to use the method log10. Okay, and that will return the base 10 logarithm. Okay, again, log by itself, log, without the 10, that's the natural log. That's the log base e of the double. Okay, so be very cautious about those. Then we've got a max to find the maximum of two numbers that we put in, and we can do that max method with doubles, floats, ints, or longs. And there's a min as well to return the smaller of two numbers. So same thing, we can input a double, a float, an int, or a long into those. Okay, then there's our power that we tried already. And then this is another big one that you'll see a lot in AP Computer Science. That's the random method. Okay, random is going to generate a random number that is between 0, 0.0 as a double, so including 0, but up to and not including the 1. Okay, so 9.99 repeating, but not equal to 1. Okay, so let's play around a little bit with that random number generator. So if we want to generate a number that's random, okay, so let's declare a double, and we'll call it, we'll just call it num for number. So double number equals, and then we're going to do math.random. Okay, now the range for math.random is starting at 0. Whoops. Bracket, because it includes the 0, so 0.0, up to but not including, so I'll close that interval with excuse me, a parentheses. Oh, whoops, I'm back in Python again. Let's make that comment correct. Okay, so the range is 0.0, a double between 0 and 1, up to but not including the 1. So let's go ahead and run that. Oh, I forgot to print it out so we could see it. That was silly. So let's go ahead and system, whoops. Okay, well, system.out.println, and then our number. Okay, so we can see what that one is. And there's our random double, right? It's a 0.039089, etc. Okay, and that should be different now if we run it again, right? Now this time we get 0.2743, etc., etc. Notice each time we run, we're going to get a different number because it's randomly generated between 0.0 up to, but not including the 1. Okay, there we got a high one, 0.387. Okay, now if I want to change the range, okay, so we'll call this one num2, okay, math.random. So if I want to take that randomly generated number, and instead of having it go from 0 to 1, I want the range to go from 0 to 6. Then I'm going to multiply it times 6. So, oops. So now the range is going from 0.0 and up to, but not including, 6.0. So let's go ahead and run. Oh, I forgot to output it again. So we'll change this to a num2 this time. There we go. And now we should be able to see some larger results come through. Right here we get 4.035. If we run it again, right, 1.832. 3.128, right? We're getting larger than we did with just math.random. Okay, now what if I want my range to have a higher bottom value? So what I would do then, let's go ahead and copy this line. We'll paste it. Okay, I'm gonna change this one to num3, and I'll put 3 there right away so I don't forget. So if I want this range to go from 3 as the base number, then I'm going to start with a 3. So 3 plus, then my randomly generated value, and if I want that to go up to a maximum of 6, then I'm going to need to change this to a 3. So let's go ahead and run. Okay, and there we've got 3.6, right? Let's run it again. There's a 4.02. We run it again, 3.14. Notice all these values are between 3 up to not including 6. So this one, 5.89, is pretty close to that upper bound, but it's never going to actually equal the 6. Okay, now if we want to generate a random integer, then we're going to change this double data type out front to be an int. We'll call this one number 4. Okay, and we're going to need to cast this result, the math.random times 3, to be an int. So let's go ahead and cast our math.random. Now make sure you have parentheses around this entire expression, math.random times 3. If you forget the parentheses and you just cast math.random as an int, right, that's going to always equal 0. If we want to make an integer between 0 and 3, then we've got to cast that product, math.random times 3, as an int. Okay, and that would be an integer 0, 1, or 2. It's not going to include the 3, again, because the upper bound is non-inclusive. So this time, the range is going to be from 3 to 6, right, as integers, not including that upper bound of 6. So let's go ahead and run. And our random number is an integer this time that was generated. It's a 5. right? Next time we get a 4, right? Next time we got a 3, then a 3 again, right? Then a 5 again. Notice we're never going to get a number that is higher than 5 because the 6, the upper bound, is non-inclusive. Okay, so let's copy this line and we'll paste it down here. This will be our number 5. Okay, and this time we're going to change this code so that we have a range that is between, let's do between 0 and 11. So if my range is between 0 and 11 and it's generating an integer, right, that means it's going to output an integer between 0 and 10, right? It could include the 10, but it won't ever be 11. So if that's the range that we want, then we're going to need to get rid of this plus 3 so that our lowest possible value could be 0. And then we're going to stretch this out to 11 because we want to be able to output an int between 0 and 10. Okay, so let's go ahead and test that one. Okay, and there's our random integer 9. That's between 0 and 10. Right, there's 8, 9 again, 7, 7, 8, 5. Right, there we got one that was lower. 0. Okay, so you've got the idea. It's generating random integers between 0 and 11 with 11 non-inclusive. Now, if we want to play with some of our other math functions, we could try math.min. Okay, and then let's see what the minimum is for num4 and num5. Okay. So it would probably be helpful if we know what the numbers are to be able to tell if the function or the method is working. So let's say the min of, and then we can concatenate that with num4 plus, and then we'll concatenate that with num5. Need another plus sign. Okay, and then is, and then we'll concatenate that with our math.min, finding the smaller of the numbers 4 and 5. So let's go ahead and give that a try. Okay, so the minimum of 3 and 10 is 3. Okay, that looks correct. Let's try it again. Okay, the min of 5 and 2 is 2. Okay, I could also compare the max. So the max value of number 4 and 5, and then we'll change this to math.max, and we'll see how those comparisons turn out. So the min of 3 and 2 is 2, but the max of 3 and 2 is 3.